That was awesome. Hi, and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Magnus. Magnus, how you doing?
Hi, I'm fine, Timothy. How are you?
I am really good. We're in the ML booth. It's my favorite booth.
Yep.
Don't tell the other booths that.
Of course not. It's exciting in here.
So, in this sandbox, we are looking at, right now, we're in a track, and there's cars going around.
Exactly.
What's happening here?
This is a self-driving car track. These are actually something called Donkey Car. We'll post the link later on to these things. You can build them yourself. There are full instructions on the internet. It's built on Raspberry Pi, and we put a TensorFlow Lite model on there, running Keras, and then we train them around this track, and they're capable of going around like this.
That's really cool.
Yeah, it's amazing. So Raspberry Pi was just a supported platform by TensorFlow Lite, so it's really opens up a lot of possibilities to do these kinds of things. So it's really, really exciting.
Well, and this is just so delightful. I saw them training it earlier, where there's just a phone on it, and he was operating it with another phone, and then the autonomous vehicle used that model built on those driving instructions.
Exactly. So it takes images when it's going around the track, and then it's using those images to train the car so it knows where to go and also how fast to go in each of the segments of the track.
That's really cool.
Yeah.
All right, what else do we got going on in this sandbox?
So as we heard from the keynote, we just launched a new version of the TPU V3. Should we check that out?
Yes.
Cool.
Over there?
Yeah.
Let's do it. Wait a second. I think I see Zach Stone over there. Is that Zach?
That's right.
You think we can get him over here? So this is TPU V3.
That's right. This is our latest and greatest TPU. This is just a part of the TPU pod that contains many boards like this.
How many?
Enough to deliver more than 100 petaflops of compute. That's kind of hard to think about, 100 petaflops.
How do you contextualize 100 petaflops?
So it's not quite apples to apples, but some of the top supercomputers in the world are only doing, a few more than 100 petaflops. And so we use reduced precision that's appropriate for machine learning. So like I said, this is not a direct comparison, but there are very few computers in the world that can do more than that many mathematical operations per second.
That's really cool. And we were talking to Jeff yesterday. He mentioned that this is the first liquid-cooled component in our data centers.
That's right. To the best of my knowledge, this is the largest scale liquid cooling system that we've deployed here at Google.
That's exciting, and it's really pretty.
I'd love to have one of these in my living room. On my wall. All over my house, actually. That would be great.
So a little bit more background on what people are doing or will be doing with something like this soon.
Sure. Well, so today, if you look over here, that second generation system, that's a cloud TPU. Anybody with a GCP project, there's no more requesting quota, waiting in line. Anybody today can start up a cloud TPU and use one of our open source reference models for image recognition, for speech recognition, for machine translation, language modeling, even generating images from scratch, pixel by pixel. And it all runs on this amazing self-contained supercomputer here. That's 180 teraflops over there. And so that's pretty exciting. We're trying to make machine learning acceleration affordable and accessible to everybody. And then we are just relentless about pushing the envelope of performance with these new generations of hardware like you're seeing here.
Awesome, Zach. Thank you so much.
Anytime.
All right, Magnus, what's next?
Okay, cool. Let's go over and check out an object detection robot at the TF Lite stand.
I love robots. Let's do it.
So basically here we have a TensorFlow Lite model running on a Raspberry Pi. This is a very cheap and easy to find computer, and what we've done with it is we've added a servo motor, or two servo motors, that can actually point the camera in different directions. So the TensorFlow Lite model detects objects, and then it tries to center them on the screen. So it's like a virtual camera person that's able to keep things in frame as they move. So if you take the apple or the banana and you put it in the frame, it will start to actually move the camera.
So what this thing is doing is that it's presenting us with words, and then it knows related words by having been trained on a huge data sets that puts those words close together. And then we use our brains to do the association, and if the answers are matching each other, then I'm successful, otherwise I'm not.
And this seems like, just fun, but what's represented there is like a dramatic reduction in the work to build something like this, because the associations are created by a model rather than a whole bunch of people working all those rules together.
Yeah, exactly. And these models, they actually exist pre-built, so you can actually reuse one in your own app. You should definitely check out a technology called TensorFlow Hub on tensorflow.org, where we have these types of models available. The classical example for this relationship is if you take Paris and then you add France and then you subtract Italy, what do you get?
Something else?
You get Rome, right?
Sure.
Exactly, and that's how we calculate the distances between these vectors. So Paris is related to France in the same way that Italy is related to Rome.
Okay.
Yeah. So I'm playing a game here, and I need to associate things with the word here and bring it down into the grain area here. As you can see, I wasn't. So school. What is association to school for you? Pupil.
Homework?
Yeah. Pupil is fine. Okay, because that's nice. I took that out. Now. So what the machine learning algorithm knows, it knows about all of these associations. So garden is related to hose, shoe is related to
Foot.
foot. Yeah, good job, Timothy.
Thank you,
The
Magnus.
newspaper is, what should we do? New York Times? Whoa. Yeah, it's a newspaper, right? So I bring these words down, and eventually it's going to build up. So I got to get faster and faster at these things. Horse, riding. Okay, so let's see here. We now have hamster, hamster, fluffy. Fluffy worked, yeah. Motorcycle, fast. No, motorcycle.
Riding.
Ride. Well, yeah, that's right. Summer, winter, hot. Summer, hot.
Thanks for the tour, Magnus.
You're so welcome, Timothy.
And if you'd like to learn more about TensorFlow, head on over to tensorflow.org. If you'd like to learn more about any of our developer products, sign up at g.co/dev/form. See you next time.